Hello everyone. So welcome back to the good stuff that we've been doing. Today in this video we're going to try to find this double sum. So it says the sum from a equals to 1 to infinity and the sum as b runs from 1 to infinity of 1 over a plus 3b to the third power, and it has a very interesting expression here. Here zeta, this is zeta of 2, and zeta of 2, of course we know this to be, zeta of 2 is known to be pi squared over 2, although the value of zeta of 3 is a constant. It's called Apéry's constant. It's called Apéry's constant, but it's well known. And then of course this is pi. So let's see how, if we can be able to evaluate the sum. Now to do that, let's quote the sum again. Let's forget about the final answer. The sum here in question is the sum as a runs from 1 to infinity of this, infinity of the sum as b runs from 1 up until infinity, and then we'll have a 1 over a plus 3b to the third power. Now to evaluate this sum, we need to focus on this inner expression here. And if we recall, we know that, for example, that 1 over a to the s power, let's say 1 over a to the s power is 1 over gamma of s, and times the integral from 0 to infinity of what? T to the s minus 1. Then you have e to the negative at. This is a well-known formula. Now, if we take a to be, let's say 1 over a plus 3b to the s power, this will be 1 over gamma of s, and then the integral from 0 to infinity of what? T to the s, of course the t here, t to the s minus 1, e to the negative, then you have a plus 3b t, then the t here. So which means that 1 over a plus 3b to the third power would be 1 over gamma of 3 times this, the integral from 0 to infinity of t to be t squared e to the negative a plus 3b t dt. Now, so how we proceed here is that this is of course equals to half of the integral from 0 to infinity of t squared e to the negative a plus 3b t dt. Now notice here that this is most interesting because we have been able to reduce this into an integral. Of course, it may look complicated though, but this is the right way to go because we cannot evaluate this sum directly in this case here. So if we can maybe convert it into an integral, maybe that will work for us. So in this case, this is our sum s, which is the double sum as a runs from 1 to infinity and then b runs from 1 to infinity of what? 1 over a plus 3b to the third power. This is a double sum would equals the sum as a runs from 1 to infinity and then also as b runs from 1 to infinity. Then you have the integral, half of the integral from 0 to infinity of what? E to the, t squared e to the negative a plus 3b t dt. So now what we can do here is that we can swap in summation and integration. So we can have this as half of the integral from 0 to infinity of what? Then you would have the sum as a runs from 1 to infinity. Now you can, this e to the negative at, you just write it here, e to the negative at, and then times the sum as b runs from 1 to infinity of, okay, of course this is a t square here, because we can factor out e to the negative at from, let me just put it in a much more, maybe for viewers who may, so that you don't get lost with my argument. Here we have integral from 0 to infinity of t squared. Then you have the sum, the double sum, as a runs from 1 to infinity and as b runs from 1 to infinity. Then you have e to the, this e to the negative a plus 3bt, you can write it as e to the negative at times e to the negative 3bt and then dt. Now notice something here, that because we are summing b's, this is a constant here for this first summation. So we can always factor it out and bring it into this second sum. And this is what we're going to do. This will lead us to have the integral from 0 to infinity of t squared. Then you have the sum as a runs from 1 to infinity of e to the negative at. Then you also have the sum as b runs from 1 to infinity of e to the negative 3bt and dt. So you see how we'll be able to convert this sum. Although this may look complicated more, but it's actually much more easier to do than this one that looks deceptively simple. So let's continue from here. Throw this down. So we are going to continue and write this as so let me just, so that I don't make mistake on that part. So this is going to equal the integral from 0 to infinity of, this is half, of course, of t squared. Then you have e to the negative t, 1 minus e to the negative t. Like, this is a geometric series, of course. And then you have multiplied by e to the negative 3t, all divided by 1 minus e to the negative 3t. Then you have dt, which is going to equal half integral from 0 to infinity of t squared e to the negative 4t, all divided by 1 minus e to the negative t and 1 minus e to the negative 3t, then dt. Now, what we need to do here is we're going to make some substitutions here that should probably do the job for us. We're going to here take t. We're going to take x to be e to the negative t. So notice that if t is 0, then x is 1. So if t equals 0, x would equal 1. And also notice that if t be infinity, x would be 0. So the limit will be from 1 to 0. And then notice that if x is e to the negative t, then what this means here is that e to the negative t is equals to log x. So t would be negative of log x. Okay, so therefore dt would be negative negative dx over x. So dt will be negative dx over x. So basically, this our sum, this everything here would become, of course, half the integral from 1 to 0 of, this is t squared. T squared would be logarithm of x squared. So t squared here would be logarithm of x all squared. So this is logarithm of x all squared times e to the negative 4t is x to the 4th power. And you're dividing this by what? By 1 minus x to the 3rd power. Then you have negative dx over x. So this would give you half the integral. Now, because of the negative, we can flip this to be 0 to 1. Then you have one of the x's cancel out. So you have x to the 3rd power. Then you have log x to the 2nd power, all divided by 1 minus x, and then 1 minus x to the 3rd power dx. So this, our double sum s, has been reduced to this integral. So essentially, what we have shown here so far is that this, our double sum only, is equal to this half the integral from 0 to infinity of what? X to the 3rd power, logarithm of x, all to the 2nd power, divided by 1 minus x, and then 1 minus x to the 3rd power dx. So if we can evaluate this definite integral, whatever the value is, it should equal to the this sum, and hopefully this integral would equal all of this. Now let's see how this can be done in our case here. So we have this integral. What we need to consider here is that, let's forget about the log s. Let's consider the expression here, which is x to the 3rd power divided by what? 1 minus x and 1 minus x to the 2nd power. If you use partial fraction, of course, I won't show the details here, but it should be easily done for basic calculus scales. If you use partial fractions, this should equal 1/3 of 1 over 1 minus x to the second power minus 2/3 of 1 over 1 minus x. Then you have plus 1/3 of 1 plus x, all divided by what? 1 plus x to the second power. So this is what you would get if you use this is what you would get if you do partial fraction. So we can split it into partial fraction. So basically, how we can proceed from here now, let me demarcate this. So how we can proceed here is that the integral from the let's forget about the half first. The integral from 0 to 1 of x to the third power, then you have log x all squared all divided by 1 minus x, and then 1 minus x to the third power is going to be the integral from 0 to 1 of, now you have, for this first case, you have 1/3 of what? Logarithm of x all squared all divided by what? All divided by 1 minus x to the second power. Then you have to minus 2/3 the integral from 0 to 1 of logarithm of x all squared all divided by what? All divided by 1 minus x. Then plus 1/3 of the integral from 0 to 1 of logarithm of x multiplied by 1 plus x all divided by what? All divided by 1 plus x to the second power. So there you have it. Now, how can we now proceed from here? Okay, what we need to do is these are three integrals. So we're going to do the first one. So let's call the first one, this I sub 1, to be the integral from 0 to 1 of logarithm of x all squared divided by 1 minus x all squared. Let's evaluate this integral. This is equals to, okay, this is 1/3. This is equals to 1/3 of the integral from 0 to 1. Now, we have a logarithm of x all squared. Then, but this expression, 1 over 1 minus x squared, is derivative of the geometric series. For example, let me show something here. Like, let me put it in a different color. We know that 1 over 1 minus x is just the sum as n runs from 0 to infinity of x to the n. Then if you take derivative of this, you have 1 over 1 minus x all squared will be the sum as n runs from 0 to infinity of n x to the n minus 1. So basically, this is equal to the sum as n runs from 0 to infinity of n x to the n minus 1. So we can continue and we can swap summation, and we get 1/3 of the sum as n runs from 0 to infinity of n. Then you have the integral from 0 to 1 of logarithm of x all squared times x to the n minus 1, of course dx. Okay, I forget all this. Don't worry, we are putting the x to all of them. You are taking derivative with respect to x, of course. Sorry, my bad. So this is the x. So here you have 1/3 of the sum as n runs from 0 to infinity of n. Then here, because of the logarithm of s squared, this is just partial square partial n squared of what? The integral from 0 to 1 of what? X to the n minus 1 dx. Okay, so if we continue in this fashion, you should have this to be equal to, let me just put a full page here. This is equals to, okay, let's bring this over here. Okay, this is equals to 1/3. Let's take back a bit. Yeah, this is equals to 1/3 of the sum as n runs from 0 to infinity of what? N partial square partial n squared times what? This will be the derivative of this will be 1 over n. So dx. No, not dx again. Now, what we can do next is to notice that let me change color. What we want to do next is that notice that this is equals to, if you take derivative of this, you will get an extra factor of 2. So you get 2 over 3 times the sum as n runs from 0 to infinity of n times 1 over n to the third power. So this would equals 2/3 times the sum as n runs from 0 to infinity of 1 over n squared. So this will be 2/3 times what? 2/3 times pi squared over 6. So that would be pi squared over 9. So this first integral, so I1, which is I think 1/3 of the integral from 0 to 1 of logarithm of x all squared all divided by 1 minus x to the second power is equals to pi squared over 9. And we'll put this in box. So we are 1/3 done with the job. We need to find the second integral. Where is it? The second integral here. So let's come over here. So we need to evaluate. So I sub 2 is equals to what? I sub 2 is the integral. Let me check. Negative. So let's say negative 2/3. I sub 2 is negative 2/3 of the integral from 0 to 1 of what? Logarithm of x to the second power all divided by 1 minus x. Okay. So again, we're going to use our method. This is going to equal negative 2/3 of the integral from 0 to 1 of, then you have a logarithm of x squared times the sum as n runs from 0 to infinity of what? Of x to the n dx, of course, dx. Then this will be negative 2/3 times the integral from 0 to 1. Let's say logarithm. Okay, let's swap summation and let's swap summation. This is sum as n runs from 0 to infinity of the integral from 0 to 1 of logarithm of x all squared, then multiplied by x to the n dx. So this will be negative 2/3 as the sum as n runs from 0 to infinity of partial squared partial n squared of the integral from 0 to 1 of x to the n dx. So let's switch. Let me try this color red. Let's see. Okay. Yeah. So this will be equal to negative 2/3 times the sum as n runs from 0 to infinity of what? This is a partial squared partial n squared of 1 over n plus 1. Okay, so this will be negative 2/3 the sum as n runs from 0 to infinity of what? We have a factor of 2 at the top there, so you have 2 over n plus 1 all squared. So that would be negative 4/3 times the sum as n equals 0 to infinity of 1 over n plus 1 all squared. Now notice that this is the derivative of the all right, I was squared. No, this is cubed. This is cubed. So right here, this is going to be cubed, and this is going to be cubed as well. So cubed. So notice that this is the derivative of the this is similar to the derivative of the diagonal function. Notice that we know from theory. Let me come over here to this side there so I can show something here. So from theory, okay, we know that phi of x, a piece of x is equals to 1 over x plus 1 over x plus 1 squared. No, that is piece prime of x plus 1 over x plus 2 squared up until infinity. So piece prime, second derivative of the diagonal function of x is going to be equals to negative 1 over x squared. No, sorry, this is x squared. Negative 1 over x cubed, of course. So negative 2 over x to the third minus 2 over x plus 1 to the third, and then plus 2 minus 2 over x plus 2 to the third power. So basically, if we this negative 1 over 2 times piece prime of x is going to be 1 over x to the third power plus 1 over x plus 1 to the third power plus 1 over x plus 2 to the third power. So basically the sum as of 1 over x plus n to the third power as n runs from 0 to infinity is going to be negative 1 over 2 piece prime prime of x. Okay, so basically when x is 1, so that is the sum as n runs from 0 to infinity of 1 over n plus 1 all cubed. This will be negative 1 over 2 piece prime prime of 1. So this case, this is equals to negative 4 third times negative 1 over 2 piece prime prime of 1. So now notice that also piece prime prime of 1 is negative 2 zeta of 3. So this will be negative 4 third times okay, this is just positive 2 third. So this is 2 third times piece prime prime of 1, which is going to be 2 third times 2 third times is going to now become negative 2 zeta of 3, which is going to be negative 4 third zeta of 3. Okay, so now what does that mean for us? Well, that means that the second integral we're looking for, the second integral, where is it? This second integral we're looking for here, which let's code the result below. This I sub 2 is going to, which is the negative 2 third of the integral from 0 to 1 of the logarithm of x all squared all divided by 1 minus x dx. This is equals to negative 4 third of what? Zeta of 3. That is it, negative 4 third zeta of 3. Now, if we come over to this problem here, you can see that of all these three integrals, this one is the first one, and this is the second one. We have the value of the first two, remain this third one. If we can get this third one, we combine everything and we are in good shape. So let's do the third integral and see. So the third integral here, which is I sub 3, is equal to logarithm of the integral. Okay, is 1/3 of the integral from 0 to 1, right? Of logarithm of x all squared, then 1 plus x, and you're dividing this by 1 plus x squared dx. Now notice that if we multiply by 1 minus x and then 1 plus x squared, if we do this, we are going to have 1 minus x to the third power. So we can multiply top and bottom by 1 minus x. So we are going to have 1 over 3 times integral from 0 to 1. So you have logarithm of x all squared. Then you have 1 minus x to the second power all divided by 1 minus x to the third power dx. Of course, the reason we are doing this is going to be clear soon, because we're going to write this as 1/3 of the integral from 0 to 1 of, then you have logarithm of x all squared multiplied by 1 minus x squared. Then you have the sum, the sum as n runs from 0 to infinity of what? X to the 3n dx accompanied with it. So which is 1/3 of the integral from 0 to 1 of logarithm of x all squared. Then you have the sum as n runs from 0 to infinity of what? X to the 3n minus x to the 3n plus 2, then you have dx. Of course, the reason for this is because we brought this 1 minus x squared inside the sum. Yes, so then we can, let's continue on this side. Let's take this out and let's switch some color. So let me switch to this. So now this would equal, we can then bring the sum. So this will be 1/3 of the sum as n runs from 0 to infinity of what? The integral from 0 to 1 log x squared. You then have the sum, no, not the sum, like log x squared times x to the 3n minus x to the 3n plus 2 dx. So this is 1/3 of the sum as n runs from 0 to infinity of what? This will be partial squared over partial n squared of the integral from 0 to 1 of x to the 3n minus x to the 3n plus 2 dx. So this will be 1/3 of the sum as n runs from 0 to infinity of partial squared partial n squared. Then you have 1 over 3n plus 1 minus 1 over 3n plus 3. Oh, then as well, I have to, because if we take derivative of x to 3n, we have a factor of 9. So this should be 27 here. Let me take this out. That should be 9 times 3 here. So this should be 27 here. So, okay, no, I've not even done the derivative here. Okay, yes. So this will be 27 here. This is 27 here. So if we take derivative of this, if we factor out 3, still more. We take derivative of this. Let's factor out 3 before we take derivative. Factor out the 3, you have 1 over 81, because that will be 3 to the 4th power times the sum as n runs from 0 to infinity of what? Partial squared partial n squared 1 over n plus 1/3 minus 1 over n plus 1. Okay. So let's take this to the next page now. Okay, let me see. So this will be 1 over 81 times the sum as n runs from 0 to infinity. Now you have partial, if you do the derivative, you will have 2 over n plus 1 to the n plus 1/3 to the 3rd power minus 2 over n plus 1 to the 3rd power as well. And of course, so let's see, we can factor out the 2. So we have 2 over 81 times the sum as n runs from 0 to infinity of 1 over n plus 1/3 minus 1 over n plus 1 to the 3rd power. Now, remember this series we concluded that the sum, recall, this inner sum will be negative 1 over 2 times the diagonal of 1 over 3. So that would be the negative 1 over 2 cancel out the 2 at the top. So we have 1 over 81 times the sum as n runs from 0 to infinity of what? No, not sum again, times, you now have negative piece prime of 1/3. Then you have plus, because of negative, you have piece prime of 1 as well. So this will be 1 over 81 times, this will be piece prime of 1/3 is negative 26 zeta of 3. Then you have minus you have 4 pi cubed of 3 root 3. The reason for this is because if you check your Wolfram Mathematica, the value of piece prime of 1/3 is equals to negative 26 zeta of 3 minus 4 pi to the 3rd power all divided by 3 root 3. Okay, so therefore then you also have to add now zeta prime, no, piece prime of 1 is negative 2 zeta of 3. So there you go. Let's see, then this will be equals to 1 over 81 times, then you have positive 26 zeta of 3, then plus 4 pi to the 3rd power over we can do this as 3 times 3, 9. Let's say 9. So 9, then square root of 3 pi cubed. Okay, then plus the minus 2, minus 2 zeta of 3. Okay, 2 zeta of 3. So if we combine them, you have 1 over 81 24 over 24 zeta of 3. So zeta of 3, okay, plus what? Plus you have 4 pi cubed square root of 3 over 9 pi cubed. Okay, so if we, I think 24 and 81 can divide, because yes, I think if you divide 81 by 3, you would get 27. Yeah. Then, but if you divide 24 by 3, I believe you should get 8. So this is going to give you 8 over 27, 8 over 27 zeta of 3. Then you have plus 4 pi cubed square root of 3 over 729 pi to the third power. Okay, so let's put everything together so far. We began by considering the sum as A runs from 1 to infinity, the double sum as B runs from 1 to infinity of what? 1 over A plus 3B to the third power. And we converted this to equal half the integral from 0 to 1 of what? X to the third power. Then you have logarithm of x all squared. Then you have 1 minus x, and then 1 minus x to the third power dx. So we say this is equals to half of, first of all, you have the series of integrals we have considered so far. We did partial fraction first, and to begin with, we did partial fraction. So we got 1/3 of the integral from 0 to 1. Then you had logarithm of x all squared, all divided by 1 minus x squared. Then also the next integral, we had negative 2/3 of the integral from 0 to 1 of what? Log of x all squared, all divided by 1 minus x. Then finally, we also dealt with the integral of 1/3 from 0 to 1 logarithm of x all squared. Then you have 1 plus x, and you have the 1 plus x squared. So, but we have all the values together now, and this is equals to half multiplied by the first one. I think we got pi squared over 9, and then the second one we had, let's check what we had for the second integral. Negative 4 over 3 zeta of 3. That is what we had, negative 4 over 3 zeta of 3. So to be a minus. So now this is 4 over 3, and then you have zeta of 3. Then the third one is not too far from us here. It is going to equal 8 over 27. So you have plus 8 over 27 zeta of 3. And then finally, that would be 4 pi cubed root 3. So you have 4 pi cubed, 4 pi cubed square root of 3 over 729. Okay, so now the half multiplies. Okay, let's first of all, this is going to equal, let's add the inner expressions first. This is going to equal half times, okay, pi squared over 9 minus, if you combine these two, I think you multiply the top and bottom by 9. So 4 times 9 is going to be, let me check. Of course, I can do 4 times 9, but I've talked so much, I forgot what 4 times 9 is. 4 times 9 is going to be 36. And if you add 36 to 8, you will get, what's, so if you do 9, so you are going to have 4 times 9 rather. 4 times 9 should give you 36. If you subtract 8, you will get 28. So this is negative 28 over 27 zeta of 3. Then you have plus 4 pi to the third power, all divided by 729. Okay, square root of 3. All divided by 729. So if you multiply everything by 2, you get pi squared over 18 minus 24 over 27 zeta of 3, and then plus 2 pi cubed square root of 3 over 729. Now notice that of course zeta of 2 is pi squared over 6. So basically pi squared over 18 can be 1/3 of pi squared over 6, so which is 1/3 of zeta of 2. So you can write this as 1/3 of zeta of 2 minus 24 over 27 zeta of 3 plus 2 pi cubed square root of 3 all divided by 729. And if you check the statements of the problem, the first statement of the problem over here, so that is exactly what we have here. So we have completely solved this problem. Thank you for your time. So please do subscribe to the channel. Bye.